Hey everyone, in this video, I want to share a small project that sits right at the intersection of machine learning and AI. While exploring AI agents, I got curious about how these two systems could be combined and what kind of results we could actually get from that. Also, just a quick reminder, if you've got a project idea you'd like to bring to life, I'm totally open to collaborating or just drop your ideas in the comments. Alright, so let's break down the architecture of the project. It's pretty robust and built around two core components, a system of AI agents and a separate machine learning module. Now, here's how the data flow actually works. First, the orchestrator agent receives a task to generate a report based on a dataset. For this project, I'm using a dataset from Kaggle. You can use the same one as well, and I'll leave the link in the description. Once the task is picked up, the orchestrator passes it along to another agent who is responsible for defining the parameters needed for proper segmentation. This agent handles both numeric and categorical features, and once the parameters are set, it writes them to a shared agent context. After that, the clustering agent takes those parameters from the shared context and launches the machine learning model. While the ML routines are running, we use special hook functions. At those points, we generate and save reports on clustering and segmentation back into the shared context. Finally, a separate reporting agent is triggered. It takes the results produced by the ML model and uses them to compile the final report. Alright, quick overview of the dataset. It's stored locally and used as input for the model. It contains information about student performance, attendance, and a bunch of other relevant metrics. Alright, let's dive into how our ML model works. You can find the full code on the project's GitHub, which link will be in the description. So, if we break it down step by step, here's what's going on. First, the model reads a CSV file with student data. Then it filters out any invalid entries. For example, if the gender is marked as other, we drop those rows. After that, we move on to pre-processing. This includes standardizing the numerical features and applying one-hot encoding to the categorical ones. Then comes the part where we figure out the best number of clusters. We do that by analyzing silhouette scores across different k values. Once we've got the optimal k, we apply k-means clustering using that value. And finally, the model generates a detailed report that breaks down the characteristics of each cluster. For testing the model, we are going to define the parameters manually for now. Later on, this part will be handled by an AI agent. So, we pass in the parameters and observe how the model generates a report based on student groupings. It also performs a comparison of different features across those groups. By the way, the model is quite flexible. It is designed to handle any dataset you provide. Now let's talk about the structure of the context. It's shared across all AI agents in our system. The main purpose of this context is to manage communication between agents and store the results of the analysis. Here are its core functions. It stores clustering and analysis reports. It keeps track of task execution statuses. It holds lists of features. And it provides utility methods for accessing the data. Let's take a closer look at the agents that work with the machine learning model. So, we have an agent whose job is to run the clustering process, but since the pipeline cannot start without a set of input parameters, I've assigned it a helper agent, kind of like a tools module. This helper agent runs first and calculates the necessary parameters, which it then saves into the shared context. After that, the main clustering agent, knowing exactly what parameters it needs, retrieves them from the shared context and launches the clustering process. To test how the whole thing works, you can run a test function inside the clustering agent's file. You will see how, at the hook level, we retrieve the parameters and plug them into the pipeline. Just a reminder that the full source code, the project description, and all the details about how the agents work can be found on my GitHub. And at the end of our agent pipeline, we launch the data analysis agent. It's a relatively simple agent that pulls information from the shared context, generates insights and hypotheses, and presents them to the user. In the same file, I've also included the main orchestrator agent, which runs the entire agent flow within a single session. So if you want to test the whole process, just run it from the data analysis agents file. Alright, let's go ahead and launch the pipeline, and as you can see, We get a detailed report on student clusters, along with suggestions on how to improve their performance and better engage with them. I hope you enjoyed this video and got inspired with some fresh ideas on how to combine ML models with AI agents. Don't forget to subscribe to the channel and drop your thoughts in the comments.